Hi, I'm Arjun. I'm one of the founders of Everclear, previously known as Connext. This talk is going to be centered not as much around what we're doing, but more around some of the awesome work that's been happening in this ecosystem and the restaking ecosystem more broadly around how you can abstract away the complexities of having to restake across chains. And we kind of like pioneered this model earlier this year in partnership with Renzo, and I want to kind of tell that story so that way people can understand the impact that you can get out of building an experience where users can interact with your application from anywhere. So, restaking is great. We all love it here. I think it's such an important primitive for the Ethereum ecosystem that users are able to go and deposit liquidity into restaking protocols. But this comes at this like very big trade-off, which is that restaking protocols are largely just available on L1. And in order to actually really like give this experience, you kind of have this like really adverse situation where layer twos are sort of misaligned with restaking protocols. We realized this back in January when we started to talk to Arbitrum about whether or not they would be able to support restaking on their chain. And what they told us was something interesting, which was that they were kind of like on the fence about it because on the one hand, they want to support LRT protocols. They want to support restaking in the broader restaking ecosystem because there's obviously a lot of value to be driven from that ecosystem. But at the same time, they didn't want to lose TVL. And supporting restaking meant allowing Arbitrum users to be able to bridge ETH off of Arbitrum, draining some of that TVL, moving it to Ethereum in order to restake there. This is something that we kind of saw echoed across a bunch of other ecosystems as well, where like projects or ecosystems were kind of hesitant to provide incentives and things like that until this problem was fixed. Also back in January, we started talking to Renzo. One of the reasons we really like Renzo is because they had this like very simple philosophy around how they wanted their LRT to be designed, which was just make it as easy as possible, right? Renzo's really simple approach was like, we want a simple deposit UI on in our application, and no matter where you are, no matter who you are, you should just be able to deposit ETH and get easy ETH. It should just be like push button, get easy ETH. Turns out that experience is actually quite difficult to create, especially when you're living on L2s. And so this was sort of like the end goal that we kind of realized we wanted to produce was let users mint easy ETH anywhere, but do it in a way that they don't actually need to know that it's happening on L1 in the first place. So how did we do this? This is probably the most complex slide, so I'll spend some time like walking through how this works. We created a system where users are depositing ETH into the like Renzo Easy ETH UI. And then instead of actually bridging that ETH to Ethereum right away, we created basically a mechanism by which Renzo can mint easy ETH upfront. This mechanism uses XERC20. So has anyone here heard of XERC20 before? Awesome. It's actually more than I would have expected. XERC20 is an EIP 7281. It basically defines a standard for how bridges and other like protocol, like basically token issuers, can create tokens that can be minted by multiple parties at the same time. The use case for this is to be able to have tokens, like basically address some of the token fragmentation that exists on L2s, to allow for easy ETH as an asset to be minted both by the Arbitrum canonical bridge and then also by protocols like Connext at the time, and things like Hyperlane as they've added in the future. Now the real benefit of something like XERC20 is that you can also protocolize some of these operations. So within Renzo's like restake from anywhere protocol, what was happening was that users were depositing ETH into their L2 contracts, and Renzo was able to know at that point that they have like an economic and also smart contract guarantee that they have access to those funds, even if those funds are not yet deposited into the restaking protocol on L1. And so what they were able to do was, using collateral that was available on L1, front the ability to mint easy ETH as an XERC20 directly back to the user. So as a user, you get this really awesome experience, right? You deposit ETH, and instantly easy ETH is minted to you. Now what happens on the back end is actually really interesting, where rather than having to go and bridge at the time of the user transaction, Renzo then bridged ETH from their own kind of like vault contracts living on L2s to Ethereum in large batches to restake all at once, just like once every 6 to 12 hours. These were some like very big boy transactions. I think at the peak, they were kind of sending like, somewhere between $2 to $5 million a transaction every 6 to 12 hours, which is pretty crazy. That kind of experience was really largely only possible because they were able to abstract away the need for the user to have to go and make many, many different ETH transactions across chains. And so just to kind of like get back to the core topic, core user experience piece here, if you were having to bridge easy ETH, if you were having to bridge ETH to L1 every single time you minted easy ETH, as a user on Arbitrum, you would be paying ETH gas fees. And this mechanism to batch up all of the ETH transactions meant that users were only paying Arbitrum gas fees. So rather than paying, at the time, like $50, $60 to be able to go and mint easy ETH, you were paying cents. Incredible change in user experience. And then, of course, the last piece was reconciling these two things, right? So once ETH is restaked on L1, that is used to generate new liquid restaking tokens, so new easy ETH, and that new easy ETH was burnt directly on L1. Why? Because we knew that there was already easy ETH that had been minted on L2 from the get-go for the user. It's a really, really interesting flow where like they're basically utilizing the fact that there is this ability to mint across chains using this open standard, XERC20, to remove the need to have to think about, to like kind of like batch up the need to have to think about bridging from L2 to L1. How did this work? Or how did it go? Well, we implemented this here. And you can kind of see what happened immediately afterwards. When we first kind of started talking to Renzo about this was a hypothesis. It was a hypothesis for us and Renzo that if you provide this really, really seamless experience on L2s, you can actually grow much faster and further than you could simply by being a protocol that's isolated to a single chain. This is something that like Connext, last year when we first started talking about chain abstraction, this was the thesis that we had been positioning for the space, that like application developers need to be able to go and onboard users from anywhere, but we didn't have any proof to show that this actually results in growth. And Renzo was the first protocol at scale to really take this and say, okay, you know what? Let's try it. Let's actually make this extremely easy experience and see what happens. And you can see what happened. Renzo basically skyrocketed. They bootstrapped over $1 billion in TVL pretty quickly across all of the L2s, and then that also drove a lot of L1 growth because it just generated so much momentum for the protocol. This basically continued to grow as they continued to expand to new chains. And you can see this kind of also with their like L2 TVL, right? So this is basically the same graph, but with all of the ETH TVL filtered out. You can see just how aggressively that grew into new ecosystems to the tune of, again, over almost like $1.2 billion at its peak. Now, of course, as like the market has kind of transitioned, the restaking narrative has sort of been changing. Naturally, there has been like a tapering off of this, but we've still seen that on an ongoing basis, as Renzo continues to support new ecosystems, they continue to tap into net new markets for their product, and that's actually really, really powerful, right? We've historically had this assumption in the space that like, if you're an Ethereum user, you're also probably an L2 user. But as it turns out, for a lot of cases, this is not true. There are a ton of whales out there living on Arbitrum, living on Mode, living on Blast, living on all these other chains that are actively farming, or actively deploying capital into these other ecosystems that don't want to get out of those ecosystems because they want to support them. And so giving them the optionality, removing the need for them to have to choose, actually ends up being a really, really valid and valuable growth strategy. But, key takeaways here. One, chain abstraction works. I think one thing that we saw was that as soon as this model started to take off, as soon as Renzo proved that you can actually grow really quickly by expanding to each ecosystem, we saw a ton of other projects also reach out to us and to start talking about how can we remove the chain from the experience of using the app. And so this, I think we've sort of seen from our side, and we're using this as a really incredible case study of like, this is what it looks like to have a truly chain abstracted experience. L2 teams ended up being aligned. So one thing that we saw that also was a really, really big transition from the initial conversations we had in January was, teams like Arbitrum, teams like Mode, teams like Linnea were suddenly extremely heavily incentivized to try to help Renzo grow. So they were depositing liquidity into our protocol, they were depositing liquidity into Renzo, they were trying to like bootstrap incentives for both of our ecosystems and for everything else that was building on top. All of a sudden, it sort of aligned incentives to create this like positive sum economy for all users, which is pretty fantastic. Three, XERC20 was a really, really key piece of this. And this is maybe just a call out to open standards, where having a shared open standard around how tokens were minted and burned across chains, rather than having just like, sovereign token implementations per bridge, meant that Renzo was able to go and expand this to a bunch of ecosystems. And I'll talk about this a little bit on my next slide, but a big part of this was that they were also not really necessarily tightly coupled to us. Right? Like there were fundamental bottlenecks on where bridges can go, on where you can build liquidity. But having an open standard like XERC20 meant that Renzo had flexibility. They were able to work with us for some ecosystems and then also expand in other ways for other ones. And then lastly, just I've kind of mentioned this several times, but really, this is a really simple lesson, right? It's not rocket science. It's something that like Web2 product teams have been harping on for decades, which is just go to where your users are. Don't make them have to jump through hoops. If you're making your user bridge between chains and pay tons of gas money to use your app, they're probably not going to use your app. We don't do a great job of tracking just very simple product metrics in this space, but we did some like initial testing around this, honestly over a year and a half ago, around like, what does it look like when you actually send users to another application to bridge and then come back to use your app? And honestly, it's like 80+% of the time they're not coming back. They're just not. Like either they're having a bad user experience with the bridge, or they're going to another system and getting confused, or they run into wallet issues with MetaMask, or honestly they just give up. They're just like, you know what, this is too difficult. And I feel this, even as a user that's been in this space for like almost a decade, I feel this pain where I'm like, man, I'm gonna have to bridge. I'm gonna have to like deposit this into something else. I have to go get gas on another chain. I'm not gonna do it. But not everything was great about this. There's still like challenges that exist in this space. And these are some of the challenges that we've sort of like identified for ourselves, and then also sort of see more broadly in this ecosystem. One big one is just chain support, right? Like how do you get to every possible chain is a really interesting and open question. I mentioned earlier that not every bridge can get to every ecosystem. This is because bridges at today are really like bottlenecked by liquidity. And this is something that I'll kind of speak to in a second, but we experienced this where we were like, okay, we expanded to 6, 7 new chains with Renzo. We built significant liquidity on those chains, but eventually we got to the point where they were like, hey, we would like to get to the point where we can launch multiple chains a week. And we were like, guys, we don't know if we can do that. Now, of course, we have been able to help Renzo do that now, working with Hyperlane, working with other partners, but ultimately there are bottlenecks here. And this is one of the things that really, really needs to be addressed. Liquidity is another big one. Like the current design, the current methodology of needing to like bridge very large amounts of ETH between chains does introduce liquidity requirements, especially on L1, where you need to have somebody that is going to be the counterparty to those transactions. And in Renzo's case, we were actually doing like, there was a point where we were doing like, 20, $30+ million of L2 to L1 ETH transactions a day. It was kind of insane. And so, that is size that isn't addressed by the current market, right? There's no bridge that can address that. It's just, that is size that you really just have to kind of like go and get very, very large scale market makers, very, very large exchanges. Then even beyond that, you eventually run out of capital and there just isn't a solution for it. And then lastly, and this is really, really tied to it, is rebalancing, right? How do you, as your liquidity gets moved between chains, how do you move it back? Who ends up being the counterparty that's actually sending transactions back from L1 to L2 to build liquidity back there again? Once again, you kind of have to end up working with like larger and larger capital actors to provide these solutions. Last couple of slides. So part of what's happened over the course of this journey that we've been working on with Renzo is that we've also like grown a lot as an organization to realize that there is this fundamental problem, right? That these core challenges are not just challenges that we faced as Connext in the past, but that this whole space faces associated with working with this world where there is just like massive asynchrony between chains. Now, of course, I think in the long term, maybe we can get to some sort of like proof singularity outcome where like we have fully like single slot finality, instant synchronous computation between all chains. Unfortunately, I think it's gonna take some time. I am still trying to talk to people and build like a bull case for that myself, but realistically, it's just you're working against having to like go and improve like proving hardware, right? And that has limitations. And so how do we actually mitigate this in the meantime? To kind of address this problem, we created this new primitive that we've been pioneering called clearing layers. Clearing in traditional finance is a mechanism by which you have financial actors basically net off and settle obligations against one another. So rather than having to pay, like $420 worth of transactions. That number was chosen by accident, I promise. You actually can net those off such that it's only really a $10 final outcome transaction, right? And this happens in traditional finance all the time. This is how like Visa works. This is how the New York Stock Exchange works. And if you don't have this, right, you are just paying massively higher costs to be able to do anything. The same kind of challenge exists across chains. We sort of saw this ourselves where we were sending all of these like L2 to L1 transactions, and at the same time we noticed that because we were sending lots and lots of L2 to L1 transactions, we were giving really fantastic pricing on L1 to L2. And so users started using like the Connext bridge at the time to bridge into Arbitrum with size because it was just like really, really immensely profitable to do that. Both arbitrageurs and also users that were just like, hey, this is a great opportunity for me to get there. And so what we realized was like, well, if there's a significant amount of capital flowing in and a significant amount of capital flowing out, why are we even bridging in the first place, right? What's the point? If you're sending $1 from Arbitrum to L1 and at the same time 80 cents gets sent back, you might as well just send 20 cents. And this is fundamentally what the clearing layer aims to accomplish, is to abstract away, like basically allow for these like back-end financial actors, as I mentioned, the market makers, the centralized exchanges, the people that would actually be facilitating these interactions across chains, right? Allow for those financial actors to be able to continually have capital available to create experiences like this. Experiences where you can use Ethereum, and by this I mean Ethereum L1, from L2s without ever realizing that you're doing it. I have a longer talk on the clearing layer tomorrow here, but I'm gonna pause here for now and just as a final note say like, we think that we're kind of like an inflection point today where this space is starting to adultify and become like much more sophisticated around things like clearing, where these sorts of primitives are possible because we've progressed enough from a DeFi perspective, from a bridging perspective, that it is possible to actually like, that there's sufficient amount of volume to actually get the benefits of things like this. And so, you know, on our side, some data that we found is that like over 80% of the flows that move between chains can actually be netted off in the first place. It means we're bridging about 5 times more than we need to. I think that this is perhaps one of the most interesting avenues of exploration for the future of bridging and for the future of things like chain abstraction with protocols like Renzo.